Good afternoon. So thank you for joining today. My name is Sarah Wilkin, and today we're going to be talking about innovation in feedstocks for faster defossilization of travel and transport. Today we are joined by guests working in high-level innovation in biofuels, and we have Anna Maria Kock from Cargill, James Hygate from FireFly Green Fuels, and Louis Hoffman from Sulzer. So we will dive into a discussion about different innovations that are happening to essentially expand the feedstock availabilities, and what we've discussed is really unlocking different feedstock sources, and through technology and engineering, this is beginning to be accelerated now. On our last webinar, on episode 4, we were fortunate to have the US Department of Energy, IATA, Smart Freight Center, World Nuclear Association join. So we're really happy with the level of support we are gaining for In the Loop. In the Loop, what we're doing within the Loop is really gathering all information. I get asked to speak at a lot of different conferences with Fly Green Alliance, and I've been invited to different working groups, and that's also what we'll talk about today. And it's really about finding those the insights and intel that is useful and supportive, of course, the market that we are developing, which is the biofuel market, and then bringing it to support the decarbonisation targets that we are all working to. What it is also cross-sector sharing, and it is really about building a knowledge base so that we can do that business development that is needed in a much quicker manner. And our latest member, so although we also have SAF producers, airlines, biodiesel producers, and our latest member is Wieden & Kennedy. So Wieden & Kennedy are an advertising agency, so it's the different kind of member. However, what they are doing is working with energy transition clients. They are building branding and messaging, which is also really key in the work we're doing. So I was really happy to have them on board. They're actually the agency that created Nike Just Do It. So they're very well known for making strong, bold messaging. So it's really good to open up our membership as well. So today, what we're really going to concentrate on is a mixture of things, such as what the feedstock is. It's hydrogen, it's crops, it's residues, it's animal fats, but it's also even human waste, and James will take us into that topic later. So it's really a mix of feedstocks, and it's also a mix of technologies that we'll be discussing today. We'll be discussing pre-treatment innovations with Sulzer. We'll be discussing HEFA and also HTL, which is a new pathway for sustainable aviation fuel. And Cargill also has a lot of crushing facilities and has done some time in the biodiesel industry. And what is happening, if you are aware of policy, Refuel EU, Refuel Maritime are legislating the use of biofuels and SAF. So we know that a market is essentially being made and mandated. We have new reports from the likes of IATA discussing feedstock expansion as well. We may have heard sort of some backward news with the International Maritime Organization's carbon pricing. It was nearly being pushed ahead. However, the US is delaying their vote, which means that implementation will be overall delayed. But again, work is still moving forward. I know personally that there is feasibility studies being paid for by the EU across Africa, Asia, and the EU. So the work is being moved forward very practically. This is the feedstock report that IATA also produced just this September, and that was accelerated. So, of course, it can be discussed at different conferences this year, towards the end of this year. And I believe that, well, we'll discuss that. James, also from FireFly, attended one of the recent IATA meetings, which really is about pushing the decarbonisation work forward and discussing the topics that are potentially blockers. So all of this work is really is moving the market forward, moving the targets, and today, yeah, we'll focus on some of the maybe the innovations that you haven't heard of and some nice intel. So I'm going to hand over to Anna Maria. So Anna Maria is a biodiesel business developer and specialist at Cargill. So Anna Maria will go into some information on what Cargill has been, for many years now, actually. And I'll pass over to you, Anna Maria, and I will manage the slides. So just let me know.
All right. Thank you, Sarah. And thanks for inviting me and giving me the opportunity to speak today. So my name is Anna Maria Koch, and I work for Cargill as a business developer for biofuels. And today I'm going to present the biofuel B100, its feedstock sources and how it can help to decarbonize the transport sector. I will start with the general introduction of what B100 is, and you'll see it here on the screen. B100 is a biofuel that can replace fossil diesel. It's also called FAME. FAME is a technical abbreviation for fatty acid methyl ester, and is also referred to as biodiesel or B100. And the 100 here indicates that there's no fossil component in the blend, but it's only pure biodiesel. It is also a biofuel, which is also HVO. So there are two big types of families of biofuels. One is B100 and the other one is HVO. And both can be made from the same feedstock. So both can be made from waste oils or also vegetable oils. What differentiates them is the pathway to produce it. So biodiesel is made via a transesterification process, and HVO is made via a hydrotreatment process. So that's the difference between those products. Both are drop-in fuels, so that means that both can be used directly in the engine without any modifications. However, HVO is a bit more, from a molecule perspective, a bit more close to diesel, which means it can also be easier used in engines. On the other hand, the big advantage for B100 is that it is cheaper than HVO. So typically it's then less costly, which is due to the less costly production process of the transesterification compared to the hydrotreatment. And on top of that, B100 has no competition from the aviation sector. So from a market perspective, that's also then a price incentive for B100. So if we now look on the right side of the screen, you'll see a map with Cargill biofuels facilities in Europe. We are, as a global company, active in more regions, but today I'm going to focus on Europe. We have 3 biodiesel production plants, 2 in Belgium and 1 in Germany, and we are also active in the HVO market. And we produce first and second generation biodiesel. And what that means, you will see on the next slide. Yes, so first generation biodiesel is made from vegetable oils, or it's crop-based. So it can be made from rapeseed oil or sunflower oil. And then second generation biodiesel is typically waste-based. So if you think about used cooking oil or animal fats or acid oils, that is called second generation biodiesel. And depending on the feedstocks that you use for the biodiesel production process, that will determine in the end the greenhouse gas savings that you will have. So typically for waste-based biodiesel, the GHG savings are higher that you can achieve. That is because you have no emissions from the upstream path of the production, so no emissions from the cultivation, no emissions from the and also no emissions from the crushing of the oilseeds. So that's why you can achieve greenhouse gas savings even more than 90% if you replace fossil diesel with second generation biodiesel. If you now move to the next slide, I've mentioned before that we have 3 production facilities for biodiesel in Europe. And one of them was opened 3 years ago in 2022. That is able to run on waste oil. So it's a production facility which produces second generation B100. And you will see here on the picture that we are sourcing a lot of different waste streams for the production. We are sourcing it globally, but also locally. And we have really a full flexibility of feedstocks that can be used. So it's not only use cooking oil, but for B100, you can basically use any kind of waste materials. Yes, if we now move to the next slides, we have a look where B100 can be used. Cargill Bio 100 is actually only the in-house brand name for our B100 product, and it can go into very different sectors. So to start with is the trucking sector. We see that in the trucking sector, not all logistic companies are yet willing to invest into an electric truck. In some European countries, also the network of charging is not sufficient, as well as the reach is sometimes unsatisfying. This is where B100 comes into play. It can be used in the existing diesel trucks and just refueled in private fuel stations. Secondly, the rail sector. So in general, rail is already considered a very green mode of transport. However, there are still a lot of diesel logs running in Europe, which could also be operated with the biofuel B100. Then thirdly, the shipping sector, and here we mean the inland navigation, so inland waterways, barges that can be run on B100, but also seagoing vessels. And lastly, that's more for the travel sector. Also, passenger transport and buses could run on B100. Now, summarizing a little the advantages of B100. Yes, if we stay on that slide, the key benefits are, of course, that you achieve greenhouse gas savings up to 90 or even 95% by switching from fossil diesel to biodiesel. But also you can use your existing machinery, so there's no need to invest in any new equipment. Most diesel engines can run by default on B100, or if not, they can have a retrofit, meaning there will be some changes to the engine that it will be able to run on B100. Then, of course, in Europe, the biofuel market is regulated by the Renewable Energy Directive and the FGA, and our fuel Bio 100 is compliant to this regulation, and it's certified and verified along the chain. We have a proven track record in all of the different sectors, and we're seeing favorable environments and incentives in various countries these days in Europe. And now, if we move to the next slide, we show you some real-world examples of where Bio 100 is currently being used. First, in inland navigation, we are operating barges today with B100 to save emissions, as well as in trucking. This is for us a big market in France. And thirdly, also the rail sector. We've done a trial with Lineas in freight transport. So yes, this was my presentation. Thank you for the attention, and I'm also happy to answer some questions.
Thank you, Anna-Marie. Yeah, so I have some questions to start with. So I'm gonna just ask some questions to our speakers after that, shown some of their information. So Cargill has been developing biodiesel for many years now, and I think what many people don't realize, and you mentioned it there, Anna-Maria, is that you did so a few years ago. Yeah, explain the change. I think you've mentioned to me that a few years ago you were only one feedstock, and then what has happened since in the last 3 years?
Yes, so I think one big development is now that we have plants running not only on vegetable oils, but also we have the third plant now operating since 2022, which is running on waste feedstocks. This was also driven, of course, by policy changes favoring more waste-based feedstocks. So now we have all options to have biofuels or biodiesel made from waste oils, but also vegetable oils, depending on the customer needs and also what they want to achieve in terms of greenhouse gas savings.
Yeah, so you saw there was essentially the market was getting made, and you mentioned it is policy, and we obviously know that what you could say is you've got a portfolio of feedstocks that you've then, so you I think what you do is also you search for new feedstocks. Is that has that been the approach for Cargill?
Yes, I would say so, that we are constantly with the team checking globally, locally, but also in-house in Cargill, since we are a big, originally agri and food company. Do we have any waste streams or byproduct streams that we can optimize and use in our facility as a feedstock?
Yeah, so it's a circular approach as well. Yeah,
yes,
and then what I have been also, there has been discussion, I know we've online in Italian Ministry of Transport has evolved their policy to now include B100. There's maybe some thoughts out from the OEMs as to whether the engines accept B100, but I think what we also have seen is that the policy is evolving with regards to B100. Would you say that's the situation?
Yes, I would say so, especially also with the RED III and the translation into the national laws. We see more and more favorable policies for B100 and incentives to use it in all different member states.
Yeah, and different sectors, because as we also know, and we'll get on to SAF a bit more with our other speakers, that aviation, for SAF for aviation is now mandated in the EU and UK, and it is, despite certain policy changes in the US, it is still incentivized in the US. So it does mean that aviation is scouting for feedstock. So generally HVO, which can be a biodiesel, is basically turning into HEFA, which is the SAF pathway. So is that an issue for the biodiesel customers, do you think? Is that what's your thoughts at Cargill there?
I don't think it's an issue, but it will for sure have an impact on biofuel prices. So if SAF capacity ramps up and more HVO will go to the HEFA pathway, then for sure it will have an impact on prices. Today there is already a price gap between B100 and HVO. So B100 is cheaper than HVO today. And this price gap will most likely even widen more or widen further if more HVO goes to SAF. So that in the end could then lead to that both fuels coexist but go to different industries, right? So HVO will most likely go to the aviation sector, whereas B100 goes to other sectors such as the off-road sector, heavy-duty vehicles, trucking, which don't require HVO, but could also use B100 for decarbonization. So we believe that B100 is maybe not not the one solution from decarbonization, but certainly part of the solution, coexisting with HVO and other alternative technologies.
Yeah, especially as the kind of SAF mandates, the volume is ramping up. And then I think you also, some of your, the groups you work with are construction and farming. So price is definitely key there. So I imagine also these industries will begin to use B100 in the future. That's probably, seems
yes,
so.
could be.
Yeah. So then also, I just want to mention as well, as we have seen in the EU, there is a combustion engine ban from 2035. However, there is a lot of kind of pushback from the automotive industry on that one because they feel it's not economically sound and it isn't economically feasible, essentially. And what has happened is there's now an addendum to this full ban, which means that combustion engines from 2035, as long as they are retrofitted to accept biodiesels, they are going to be, they won't need to be completely, there won't be a complete ban essentially on the combustion engine. It will continue. So from a market perspective, some people have, of course, biofuels are a transition. However, it does seem that transition is going to be going on for much longer. Therefore, any investors or thoughts about feedstocks and volumes, it means that market is going to be existing beyond 2035, essentially. So, so that's some interesting updates from an EU and policy perspective. So thanks, Anna Maria. I'm gonna. I know James from FireFly. You were we've had our discussions as well. You were also mentioning comments about the biodiesel industry and how it's really supported the SAF industry from an innovation and technology point of view. James, do you have some comments to start off with on that?
Yeah, sure. So obviously I'm here wearing my FireFly hat today, but actually I started my journey in biofuels 22 years ago with a company called Green Fuels, where we developed biodiesel technology, and we sold it all over the world, but very specifically for second generation, so converting waste oils and fats into fuels. And this, it's good to see biodiesel making a bit of a resurgence as well. I think there are challenge areas around the availability of feedstock, and that's one of the reasons why we started FireFly. Because at the moment, when you start looking at waste oils and fats, an awful lot comes from China and Malaysia. I think the vast majority is processed in the UK. And when you look at the SAF capacity, or the refining capacity for heifer specifically, doubling this year in China, I think we're going to start to see less of this material moving around. And I think the concepts, and similar to what Cargill is saying, for biodiesel, sort of local oils for local production, probably makes a lot more sense than moving it around.
Exactly. And as you said, you are here to discuss FireFly. You are choosing a feedstock based on availability and its low cost. And actually, what it is doing is meaning there is more feedstocks for aviation when already we can see there's going to be some competition. It may affect the pricing. And I know you also, you're very key on the fact that the biofuels are all about the price of the feedstock. If you're going to have a successful business model, you need to be making sure that. So, James, you want to?
Yeah, sure. So I've got an introduction here to what we're doing at FireFly. So as I said, we really came from the traditional biofuels industry, and the challenge was always, what are you going to make the fuel out of? And when we started looking at aviation and realised the volumes that were required, we started to look at various different feedstocks that are out there. We have a research company called Greenfields Research, which was specifically set up to identify and qualify the use of different feedstocks. But when we sort of stumbled across sewage, not literally, luckily, but we realised this was a hugely abundant bioresource. So actually, it addresses two key challenges. So if you look at sustainable aviation fuel today, it's very expensive to produce. Regulations are requiring greater volumes to be used, and there's just there's nowhere near enough of it. There's tiny volumes that are actually now being produced and going to market, and it's all typically from a heifer process rather than anything else. When you look at sewage sludge is because of a change of regulations, become progressively more expensive to dispose of. There's loads of it. It kind of grows with population, as you might imagine. So we kind of figured that you could tie these two things together, which is what we did with FireFly. And when we talk about sewage sludge, it is specifically a material called biosolids, which is the material right at the end of the wastewater treatment system. If you want to move on, slide, yeah. So the editing's got a bit weird here, but basically we do we have two parts of our process, an upstream and a downstream part. The upstream part, we take biosolids, so this is the material that is currently disposed of to farmland in the UK. It goes through a process called hydrothermal liquefaction, so think sort of wet pyrolysis basically, not such high temperatures but quite high pressures, and you end up producing a biocrude and a biochar. Biocrude is quite similar to or very similar to a fossil crude, although it's fresh. So that can then go through a traditional hydrotreating route to produce a product slate of fuel. So, and we could produce a lot of diesel, but our focus is on the production of SAF, and so we end up with two key products, which is sustainable aviation fuel and a bio-naphtha. So just to give you an idea of where it comes from, I think we all know where it originally comes from, but it goes through, if you look at the wastewater industry, there's typically a primary, secondary and tertiary treatment ending in anaerobic digestion. And today this material will go into trucks. So the sludge treatment works, if you imagine, it's consolidated into these sludge treatment works, goes into trucks, and in the UK it goes to farmers' fields. And in some countries it's incinerated, in some countries it's landfilled. Actually, disposal to land is getting phased out in many places because we only have a certain amount of land bank. We like to call it the countryside, but there's a certain amount of land that you can spread this material on. Also, really because of recent discoveries in forever chemicals, so PFAS and also microplastics pollution, this is driving legislation to change to say this will start to get moved out of these current disposal routes. When you look at incineration, it's not particularly fulfilling with this material because it's 80% water, so it's quite expensive and uses an awful lot of energy to dispose of, but it will destroy the PFAS, and so that is a route that it's going for. And there are some countries where it's still landfilled, which isn't great, and so obviously that can create methane, etc. And so that's the existing system. Should I move on a slide? What we're developing is an upstream and a downstream process. So the upstream, rather than the biosolids going from a front loader into the back of a truck and off to a farm, it will go through a decentralized hydrothermal liquefaction plant, which is a big pressure cooker. You end up with your biocrude, which can then go to a refinery, and then you have a co-product of biochar. The best use of this would eventually be used on land to go back as a fertilizer, but at the moment this is being used for aggregates and for low carbon cement, etc. When you look at the hydrotreatment side, so when you look at the hydrotreatment side, that then goes, truck will then go to our refinery, and I'll touch on where we're building that, the first one in the UK, in a moment, but that then gets turned into your SAF and your bio-naphtha. Great. One of the beauties of this route is because we effectively make crude oil quickly, you end up with this complex mix of hydrocarbons, which gives you a fuel at the end, which is very, very similar to a fossil jet. It has aromatics, has cycloalkanes, etc. in there. So we've done lots of testing with many labs. DLR, for example, has some results here, but with Washington State University, etc., on this fuel. It's a new pathway, so we're going through ASTM qualification at the moment. There's a new pathway actually called sewage biosolids to jet. So if you read about that's us. But it's looking like it's a should be qualified. We're currently in tier 1 and tier 2, if you know about ASTM qualification, but hopefully over the next year or so this will become a new pathway in the D7566 annex. It's a great fuel when you start to look at very high percentage or neat SAFs, because it is basically the same as jet fuel. Early on in our journey here, we wanted to make sure that the carbon savings were significant, and we actually looked at what all the knowns. So actually our 92% saving that's mentioned here, this was actually a piece of work we did with Cranfield University to look at the overall LCA for the process. This doesn't include any carbon capture and storage, which is actually something we will be doing on the HCl side. So we have a very pure biogenic CO2 stream. So we're revisiting this this year and expect that to become actually carbon negative. But the main reason why I think it's gaining so much interest is because we have such a low or negative cost input material. You can actually see a world where you can reach cost parity with jet. And this was key. So when I started Green Fuels, basically I used to make biodiesel for my own car. The business really took off when Animal Byproducts Order banned the use of cooking oil or waste cooking oil in animal feed. Suddenly this became a waste material that we got paid to take, and that enabled us to grow the business. That enabled us to grow the business quite significantly over the years, and we're seeing something similar happening here with biosolids. Yep, you move on a slide. So we've had a lot of commercial traction. So we wanted to make sure we built some very some key partners that would enable us to scale this not only in the UK but globally. So we need to finance a plant. These things are very expensive to build. So we actually put in place one of the very first bankable offtake agreements in the SAF industry. So we have an offtake with Wizz Air. So 525,000 tons over 15 years. It has the various mechanisms you would expect in a proper offtake. So take or pay, stop loss, floor price, etc. built in. It's kind of unique in the space, but we worked with Wizz, who are amazing, brilliant partners of ours, but also with an investment bank to say, okay, how do we use this to unlock the funds required to build a refinery? We have technology partnerships. So Chevron Lummus Global. They're pretty important. So if you look up in the sky, every other aircraft will be flying on fuel produced to one of their hydrate treaters. So they are by far and away the market leaders in that space. And we have an exclusive arrangement with them for our biosolids derived bio crude, which is no different to us pulling crude out of the ground, really, and saying, can we develop a catalyst system and metallurgy to process this crude? So that's something that we've done with CLG, and they're a key partner to enable us to scale. Boeing, we may have seen announcements of Boeing's investment into FireFly as well. They're driving us to scale not only in the UK but globally to provide access to SAF to their customers, because the reality is this feedstock is everywhere. They've been incredible partners as well on this journey. We work very closely with the UK clearing SAF clearing house up in Sheffield, which has been brilliant in supporting us, and again through the ASTM process. And Skies 50 is a specific vehicle that was set up to fund this current stage of investment we're sat in, which is to bring the whole thing to FID. On the right, you can see our site. There's quite a lot of stuff there already. It's actually, we're co-locating at a small refinery in Harwich owned by Holtam and Carless. This is where we're installing a hydrotreater, then building into existing infrastructure. And I think that's really important. If anyone is looking to build a SAF facility on a greenfield site, there is a lot of stuff you've got to put in there. You need a lot of permits, and this is a top-tier COMA site, so all the permits are there. There's also 200 people who know how to run a refinery, and so utilising a lot of existing infrastructure is a way to fast track and bring it to market. We've got two of the water companies on there that are publicly working with us, so Anglian and Severn Trent, but actually it's most water companies in the UK now. They're driven to look at this, and we would say in the industry we're unusual being feedstock driven rather than feedstock dependent. So because of looking to find a cost-effective disposal route for these biosolids, the water companies are keen to into long-term agreements with us for the processing this. So there's an awful lot that's going on the commercial side along with the technical side. We have a great team that are running all these things, all these things in parallel. But it should make a significant impact to the amount of SAF produced in the UK. So not only in the UK, you may have heard about partnerships we've developed in the US. So we have a partnership with Synagro in the US, the largest processor of biosolids in the United States, and they process 16 million tonnes a year. And again, are faced with the same regulatory changes as we're seeing here in the UK. We just put that into perspective. That's about 1 billion litres of crude a year from one supplier. So it's quite. I think if you look at last year's SAF output from the US, you could double that with this new feedstock. But yeah, we also have Sanepar in Brazil. They're a large utility company there, again feedstock driven. They're looking for ways to deal with this material. And yeah, you can see where we got it in on the map. Where else we're working, they won't be totally in the public domain just yet, but it's a really exciting place to be, because there's because you're solving two problems here. There's a real drive to make this happen. Move on to the next slide. Yeah. But actually, this is really why we're going to make this happen. When I started Green Fuels, the initial plan was to decarbonise my own transport. Then it was to have quite a big impact on CO2 emissions, and we ended up saving, I think today it's about 10 million tonnes on the Green Fuels side. Set a lofty goal of how do we save a gigaton of carbon within FireFly. Obviously, we can't do it. We'd love to do it in a year because that would offset all the carbon, but actually we do have a roadmap of how to achieve that, and the aim is to we've got over 15 years, but actually the reality is we're looking at how do we save at least a gigaton by 2050 through our organisation. So that drives all of our decision making, where we're looking to do this, how we do this, etc. And so that's the why. I think that's it, isn't it? Is there one more slide?
That is the.
Is it?
So yeah.
Yeah, so anyway, feel free to reach out, and if you want to learn a bit more about this exciting new process, it's pretty cool.
Yeah, thanks, James. It is. It is a very. So we've got a question. So HTL as a pathway. Actually, if anybody knows Fly Green Alliance, we were granted by Booking.com in 2018 to advance the HTL pathway. So that was an early stage piece of work. And then what has happened with HTL in the last few years is the likes of DLR, the German research group, have really supported it. There are other technology providers that are now bringing it into their portfolio. So essentially, it is one that was being watched, and now it is being brought to fruition, because people did say, we've got all this feedstock, and actually we have an abundance of certain feedstocks, and it certainly needs to be turned into something useful. So it is, it is a win-win on many levels. So it sounds like you're developing well. I know, James, we've met at several events now. So I'll just take a question from Sanjay. So for James, is the 92% life cycle carbon reduction versus fossil fuel, does it rely on including contribution from biochar?
Yes, it does. So that is part of, so this is the overall life cycle of the process. And so there is a significant part by the point of the production of this biochar, which is why we'll be looking at, fixed carbon uses for that output. But that's great, because you're actually using it as the ultimate aim would be using it as a soil improver, where it's fixed, but actually there's a lot of demand from the construction industry for low carbon fillers and aggregates, asphalts and things like that. And the reason, I suppose, just touching on your point, so the reason we looked at HDL, we're not really we're quite lucky in our labs that we can do an awful lot of different processes. It was really around the feedstock, and I think with any feedstock you have to look at the right tool for the job for processing it. And this because it's such a wet feedstock, purely thermal processes didn't really work. They weren't sufficient to dry it and, you know, to then gasify it, and then to go to FT, turn it into liquid fuels, etc., which we tried. But actually, yeah, HCl works really well for these sorts of materials, and we see a great opportunity to expand in that field. And we're relatively technology agnostic when it comes to the HCl. I think the key parts where we have the ability to scale is really with this partnership with CLG, because a lot of it is around how do you get this crude, because it is fresh crude. It's not like it has been billions of years, and then it's full of oxygen, nitrogen, metals. You know, there's all sorts that you've got to get out of the. You've got to basically treat the crude first of all before you then go through the processing. And so it's great to have basically the biggest company in the world doing that alongside us.
Yeah, it is very good. Yeah, it's great support, and HTL really is around what I know from it, as I've been a business developer on the technology as well, is it is about the engineering approach. It is saving, it's saving across the board.
Mm-hmm.
So it's a smart pathway. And as we also with HEFA, we now know that the HVO and HEFA are now definitely in competition from a feedstock point of view. We know there isn't complete abundance of used cooking oil. So actually starting, as our titles just innovating here, making the technology fit the feedstock is really about matching that together to make the win-win-win. So yeah, thanks, James. Really interesting information. I'm talking about pre-treatment. I'm now going to move on to Sulzer, and Louis, who is Global Licensing Director, is going to take us through some of their innovations. And it's really engineering and chemical engineering innovations, which are making sure that our carbon neutral fuels, our net zero fuels, are truly working. So, Louis, I will hand over to you.
Thank you very much, Sarah.
Yeah, thanks, James and Anna Marie.
So just maybe quickly introducing myself. Louis, working for Sulzer, based in Switzerland. And for those of you who don't know us as Sulzer well, we've been around for a while. We were founded 1775 and basically have been in a number of industries. We did make weaving machines. We did make a lot of things. Now we're mainly active in the chemical industry. Are most known for separation purification processes and technologies, and one of those are basically around sustainable fuels. What James mentioned is number 3 in his nice chart. I was a bit jealous about the visuals of your slides. I think they're a bit nicer than mine. And this was the core. And maybe Sarah, we can then move to the next slide. This is what we have been offering already for a while. It's that bioflux hydroprocessing part. And we've worked with a number of customers. And in the beginning, we saw a lot of used cooking oils, a lot of POMEs, the palm oil mill effluents. So a lot of nice feedstocks for us, something that was in a way easy to pre-treat. I think this is something that James already highlighted, and this is true for basically every feedstock. There is some pre-treatment required to do hydroprocessing. But then after a while, we realized, first, those good, clean feedstocks are getting quite a bit more expensive. And second, some of our customers actually struggle a bit with getting enough of those materials secured. And they started looking into different materials, basically higher contaminated fats, oil, greases. And we then assessed those materials together with partners that we have that offer the conventional pretreatment technologies. But unfortunately, at some point discovered that we run into a few limitations. So maybe it's the chloride level that's too high. Maybe it's the phosphorus level that's too high. We really can't bring that down to what we need for our hydroprocessing reactors to in the end last. And this was the starting point of our journey of developing, I think we can already jump to the next slide, that's fine, of developing our own pretreatment technology that we call thermal pretreatment technology. So something that is quite different from a process, from a chemistry point of view, to the existing physical pretreatment technologies. And the target was really addressing those highly contaminated feedstocks. So basically, I show that column here, typical feedstock content, the number that you see on the right. This is what we developed that technology for. So for materials that have thousands of ppms of metals, of phosphorus and chloride. So those materials that really can't be purified with a physical pretreatment technology. To really bring that down to what you see then in required for hydroprocessing. And when we developed that technology, we worked with our partner Duke. You may have spotted their name on the first slide, and we built a demonstration plant that is based in Jackson, Mississippi, and has a capacity of 10,000 tons a year. So this is where we, after some initial lab trials, proved scaled the technology, and where we wanted to see, does it really work? Can we really bring down those three components, the metals, the phosphorus, and the chlorides to where we need them to be? Tested a quite broad range of feedstocks, and in the end saw, yes, it works. And had a quite nice side benefit. In any fat, oil, grease, you do have quite a bit of oxygen. And part of that hydroprocessing technology that is then downstream of the pretreatment is actually getting that oxygen out. You don't want oxygen in your jet fuel. Basically, your jet engine doesn't like that. And we saw that with that thermal pretreatment technology, we get already half of that oxygen out. And that is a quite nice side benefit, because for every oxygen that's gone, you don't need hydrogen downstream. And hydrogen is a key cost factor for any hydrotreating technology. So yeah, in the end, we were happy with the result and translated that into an industrial concept for that process technology, which is on the next slide. And saw that in the end, we don't need a lot of complex equipment for that. So the core of the technology is in the end a fired heater. You can see that on the top right of the flow chart on the left. So something that is basically used everywhere in the chemical industry, in the refining industry, to heat up liquids. So we, in a way, misused that piece of equipment, turned it into a reactor. Don't need a catalyst, don't need any fancy reactor. And we're able to achieve that conversion that we wanted. And because we can use simple standard equipment, you see it here, pumps, heat exchangers, fired heaters, and vessels, we saw that actually the investment cost for a thermal pretreatment unit like we design it here is significantly lower than a physical pretreatment unit. We're talking about approximately a third of the investment. And next to that, we do not need consumables in the process. We do need a bit of wash water, and the wash water is in the end where we get all those impurities out, but we don't need bleaching earth, we don't need acids, we don't need bases. So in the end, it's typically significantly cheaper to buy one of our pretreatment units, but then later also to operate it. And that brings us then to our core technology, the hydroprocessing technology. And why I'm talking about that is because it integrates quite nicely with our pretreatment technology. But to show you how it integrates, I think it makes sense to just spend a few minutes on the details of the technology. I won't go into too much detail, I promise. There is one thing that makes it a bit different to other hydroprocessing technologies, which is shown on the next slide. And that is that we keep our reactors full of liquid. In a normal hydrotreating reactor that you see all over the globe, you have a gas phase. That gas phase is the hydrogen, hydrotreating hydrogen, and that hydrogen is circulated through the reactor, basically to make sure that there is always enough available. And for that, you need a hydrogen compressor, basically like the pump you have for your bike in big and expensive. And that is a quite expensive piece of equipment to buy and also to operate. Just compressing gases takes a lot of electricity. And we replaced that with a pump. So we just pump the liquid around. That's a patented process that makes the whole thing, especially at small, medium scale, significantly cheaper to buy. It comes with a few process advantages because we can control the temperature in there very well. We don't have liquid distribution problems, but maybe going a bit too much in the details. In the end, something that works, what we've seen in past projects, specifically well for SAF plants that are in the medium scale, like in the 50 to 200,000 tons a year scale. We don't only need one of those reactors, we actually need a few of them, as shown on the next slide, but this is just for those that are curious. This is the more or less full processing scheme, which we have, which can produce HVO, which can produce SAF with one physical plant in place. So we don't need to change the unit, we just change the operating parameters a bit to produce one or the other product. Yeah, so just so you've seen it, but now I'd like to move forward to the integration, which I think is the exciting part of all those technology blocks together. So you have now an idea of what our pretreatment technology looks like. We heat up materials, we break them apart a bit, especially we then extract the metals, the chlorides, the phosphorus, feed that to our hydrotreating unit. That makes, in the end, the HVO, the SAF, and a bit of renewable naphtha typically. But in both of those units, we do have an off gas. From the thermal cracking, we have the kind of backbone of the triglycerides, so the 3C3 molecule. We do crack off some lights, so we have a bit of off gas there. Any hydrotreating unit has off gas, and we can actually use those off gases in a hydrogen generation unit. We do use the most commonly used technology there, steam methane reforming, to produce the hydrogen. But in this case, and if we use the off gases from our process units, it's actually biogenic hydrogen. It's not green, but it's on a bio-based source, which is positive for the carbon intensity. And most importantly, the off gas streams that we have from the pretreatment and from the hydrotreating are sufficient to supply the hydrogen generation unit at steady operation. So we do not rely on natural gas coming from the grid, coming from fossil sources, but we can actually, after startup is done, run that unit basically self-sufficiently, because we also do have a bit of excess steam, a bit of excess heat that we can integrate in that process. And if we put that all together and combine those three blocks, this being self-sufficient is nice, but in the end, most of our customers are interested in what does that mean for my process costs? And we see that here we really see a lot of benefits. You don't need to buy expensive hydrogen from the grid. You don't need to buy the natural gas. Your carbon intensity actually goes down. The investment cost is typically lower. Something that I did not mention before is because we do remove so much oxygen in the pretreatment, the hydrotreating reactor, the first one, becomes quite a bit smaller, and that already outbalances often the cost of the pretreatment unit from an investment point of view. That altogether really brings up the internal rate of return for the customers we've seen. And it's 15% higher. So the IRRs we see are significantly over 15%. We've done that a few times already with a number of customers, which is then on the next slide. So here you see a list of projects that we currently have. I don't want to spend too much time on that, and just want to quickly show or highlight the picture on the right, because what we can do is we can pre-assemble all those things in, we call it modular units. So those frames that you see here, approximately the size of a shipping container, and that makes life for plants like the one that James showed, that are maybe a bit remote and don't have the full infrastructure for a chemical plant on site, makes construction of such units incredibly easy on site. It's basically just big Legos for grown-ups. You stack them, you connect them, and almost ready to go. Looking at the time, don't want to spend too much time more here, so we have a few minutes for questions, and yeah, thank you. I think we can skip that part for now.
Thanks, Louis. Yeah, that's great. Again, bringing seeing a problem and solving it with technology, and yeah, putting the two together. We have policy targets. We know we're on a net zero pathway, so it is great that the innovations are really coming to market. The modular approach as well. I know that I've also been working closer to small modular reactors, which is a different technology, but it does seem that in engineering process, that any sort of modular approach seems to be, it's a faster, as you said, Lewis, it's a faster way to construction, essentially. So what has the feedback been not with your clients on this? How I'm presuming, of course, it's for speed, but how have your clients reacted to that?
So it's basically two reasons why we have customers go for a modular approach. The one is what you already mentioned. It's really speed. So the picture that I've shown you was for a customer in Thailand. For them, speed was important, and for them, we managed to go from start of our engineering to having those skids, those modules ready for shipment in 1.5 years. So for them, that was really beneficial. We have other customers that are maybe not so familiar with the chemical industry, but maybe are a bit closer to the feedstock. For them, it's really the simplicity that makes the difference. You don't need to manage a chemical plant construction yourself on site. You can basically have that done in our workshops, which are perfectly set up to do that efficiently and quickly. And this is the other feedback that's quite positive that we hear from customers.
Exactly. That is an interesting point, actually, because the groups that have been coming to, they've been Googling SAF and finding me personally, they're actually feedstock supply. They realize that, well, also policy is changing. I know the rules around waste in the UK and many places are changing, which changes the value of the feedstock. And therefore, certain groups are also seeing the SAF mandates, again, a higher value for waste, essentially. And groups are really wanting to be part of that market. So this is what, so it is often, as you said, not necessarily engineers, but they're part of the process. So the feedstock suppliers are looking into whether they can be producers as well. So that has changed in the last, I would say, year. Even one of FGA's members in observer mode is a global waste management company. So they are, of course, looking at what they are doing with the whole of their ecosystem, and then also looking at different opportunities in innovation as well as technology. So that is definitely happening. And then, so what's your, and then the company history is very interesting. You're innovators, essentially. Would you say that's how you stayed alive, essentially?
I think that's how we stayed alive. We actually have, I didn't bring that today. We have an interesting slides of all the technologies that we've done. You need font size, I think 6 or 7 to bring that all on one slide.
Yeah.
And I think this is one of the core values we have in the company, to keep reinventing and to find new and better solutions. And I think
that's good. And
that's helped us being successful so far.
Yeah, and I think you're already seeing gaps, and I know we discussed there are more gaps you've seen, and so you're already innovating for next year, the year after. Yes,
I think, Sarah, we discussed it before. We have one more thing in the pipeline. Not ready to speak about it today, but I think in one of the coming seminars, I'm sure we get the opportunity to do that.
We definitely can. So great. I know we're a little bit over time now, but as you can see today, we've discussed, it's all kind of from feedstocks to technologies, of course, policy, policy change, the law change, it kind of switches the market very quickly. Obviously, different political leaders, we know that things can change every 4 years, whatever it is. So obviously the EU has been very, what's the word? Well, basically, they're saying the policy isn't going to change. This policy is going to be here for at least up to 2050. So we know that EU market is strong. I went to Argus Media recently, and there was many feedstock suppliers in the room, and also out of Europe, realizing the EU is a really strong market, as well as also groups. Member states and the EU are sticking to the decarbonisation target. So it's all, the EU and the US, as I said, Asia, Singapore's now got a SAF mandate. There's lots of feedstocks from Asia coming to Europe. So it is a fast-growing industry. It is evolving. And yeah, as you can see today, there are lots of groups constantly innovating to make sure that is happening and not at a price that is affordable for their customers, net zero managers. So thank you very much. I know we've had a few questions in the chat. Do you want to answer that one from Jeff, actually, Louis, if everyone's having to stay on for a little longer? What is the UCO to SAF conversion efficiency of your process version versus traditional HEFA?
This is something that we actually look into case by case for every customer. There is not, I mean, UCOs are similar, but they're never the same. In the end, it depends on what's your fatty acid distribution, what are the levels of contaminants that you have in there. If you have anything else in there which is not UCO, then of course we cannot turn that into SAF. So Jeff, let's just have a discussion. We can look into that for you and give you a better answer than just an approximate number I would give you here. Yeah,
so that's an LCA question. So I know that I'm also working on an LCA development project at the moment. So I think there's yeah, we can definitely calculate this one. So yeah, thank you. And I've known Jeff for a while, so hi Jeff. So thank you very much. I will stop recording in a minute. Thanks to everybody that's joined. If you have any questions, yeah, as you've seen in the loop, we want to bring information and insights and topical discussions to our members and our groups, that our community that are checking in. Everybody has got some, tough work to do, but it's good to get to know each other's work and to also support each other with introductions and cross-sector development work. So thanks to our speakers today, and I will be forwarding the recording out to everybody this week as well. So thank you kindly, and yep. I will see everybody hopefully soon online. Thanks. Have a good afternoon.
Brilliant. Thank you. Thank you so much.
Thank you very much.
Really good. Cheers.
Bye-bye.
Bye.